Okay, good morning. I'm Thomas Brickner, the instructor. This is Astronomy 2002, Introductory Astronomy. Sorry it took me so long to set up. I usually have a TA. This is section 2, and we're a big section. We'll be going over syllabus and stuff. Here's the outline basically for today. Let's go through a little bit of an introduction. Here's how you spell my last name, Brueckner. And I'm a PhD astrophysicist. My last name is German. It's pronounced Brickner, like bricks. But if you feel like you're going to raise your hand if you're a freshman. All right. Those of you that are not a freshman, you could ignore my next remark. If you feel like you're going to blow it and not pronounce my name properly, you can call me Dr. B. Right? And so that's normal. Because it's one of those infinitely mispronounceable, infinitely misspellable names. Anybody in here a senior? Raise your hand. Raise your hand if you're a senior that is graduating in December. Okay, just a couple. Good. All right. Do not let me forget it. All right, we're going to try to get you graduated. It's don't laugh. I mean, you got you freshmen that just laughed. You just see what it's like when you're a senior. Anyways, my research specialty is theoretical astrophysics. So black holes, I know all about those. Quantum field theory, I know all about that. Early universe or Big Bang theory, I know all about that, except I have never actually watched that TV show for more than about 2 seconds because I hate it. So don't ask me about the TV, but the Big Bang theory. And we'll be talking about black holes and the early universe in this course. I've got 2 big, enormous lecture sections. I have no idea what the enrollment is in here. It's over 300. As you can see, this room is nearly full. I might not even have enough syllabuses for everybody today, but we'll get some to you. As it says here in item 2, I don't have any GTAs yet, so hopefully the end of this week, or Thursday, I'll have a TA to help me up here. All right, so those are introductions. And David and Heather, you guys have already learned your names. I'll try to learn as many of your names as I can. And I have done classes of 200 before in one semester, so it is possible. If you see me on campus wandering around or something, or drinking coffee over at Starbucks or whatnot, it's pleasant. I enjoy talking with you guys, and so just come up and say, "Hi, Dr. B. and then state your name, and I'm in your morning astronomy class." Okay, you've been in one of my classes before, right? No, you. Yeah. No. Okay. No, I mean we get students that take physical science, and then they take this one. So, anyways, if you see me around campus, just introduce yourself. I enjoy it. Okay, and I'll try to learn as many names as I can. All right, now let's talk about the big question. Why are we here? Well, the reason that we are here is because of the General Education Program, GEP. And this is in the course catalog. And the Science Foundation, specifically, this is our part of the GEP. Astronomy 22 is right up here at the top. So you're knocking out or taking care of, cleaning up your GEP course requirements in this class. And I was just looking at this morning. It says high school algebra, And so we're going to do a little algebra, not a huge amount. We'll do a few equations, not a huge amount. And we'll actually do a little bit of geometry. Well, actually, we'll be talking about geometry a lot, orbits and triangulating distances and stuff. So we'll probably talk about Pythagorean theorem a little bit. But nothing too deluxe. Raise your hand if you've had calculus. See, that's the... Okay, raise your hand if you have not taken any math at UCF. See, so we have a huge range in math experience here. So we'll try to talk about all of our equations and formulas and stuff in an appropriate manner for everybody. So don't worry about that. I'm an old hand at that. Why are we here? General Ed program. Another answer to that question is Professor Galileo, who was the first astronomical observer with a telescope. We've been making astronomical observations for ages, all the way back to the Egyptians and the Babylonians and all those guys. But Galileo's the one who did two things. He started using a telescope, and he insisted, and he actually developed and generated the whole idea of physical science. And so astronomy parted ways with astrology about the time of Galileo and became a physical science of observation and measurement and calculation. Another reason that we are here is Astronomy Picture of the Day. And this is the website that I encourage everybody to look at. Astronomy, it's a NASA website. And they just have cool photos of galaxies. This one's a cool time-lapse photo of, or a series of exposures of yesterday's eclipse. Raise your hand if you observed the eclipse yesterday. Cool. I observed it on TV. I didn't get out there. Raise your hand if you used a cereal box. I saw that. A couple friends of mine out in Montana use a cereal. That's kind of a cool method. Now, the reason that Astronomy Picture of the Day is important for us in this class and explains why you are here is the following. This particular photo was made by a professional photographer, Ben Cooper, who's actually here in Central Florida. I think he lives over by the Kennedy Space Center. Does a lot of space program and astronomical photography. And on the APOD website, Astronomy Picture of the Day, there are tons of photos from amateur astronomers who started in classes just like this. And, in fact, this class has the advantage for you as a human being. Forget about GEP for a second. You as a normal, everyday human being can become an amateur astronomer and work with NASA starting in this class. And to that end, I'll draw your attention to one more thing, the objective, or one of the big objectives for us, and that is to go to the Robinson Observatory at UCF, which is down past the police station, and kind of cut a left on Libra there. We're over by Libra. And they have public viewing sessions that we will go to if your schedule permits and if the weather permits. And usually they're Wednesday nights. And you will get bonus points for your grade by attending and participating. There's 300 and something of you in here right now. Probably all 300 will not go on the same night, but if you do, I'll try to be there and help out. And the UCF Astronomy Society runs those. And the UCF it's not just physics majors and, math majors. It's guys from Astronomy 2002. There's plenty of guys in that, and this is something that they find that they really enjoy. And so you can definitely join. You can join it this semester. You go there, you like it, and you can actually participate in it and join it. They have a website, and we're going to keep a close eye on this. Notice that their schedule down there for Monday, yesterday, was in the afternoon. Now, usually they meet after sundown, of course, because they're going to be looking at planets and galaxies, nebulas, and stuff like that. And but yeah, we're going to be keeping an eye on this, and I'll be trying to encourage you on Tuesdays to get out there Wednesday nights, and then Thursdays we'll try to get a report. Who went to the observation last night? And it's always different. They always have a different set of things to observe. Jupiter or the rings of Saturn, something about the moon. Different galaxies and stuff. It's pretty cool. All right. Now, so that's why we're here. From the GEP program at UCF all the way to Galileo, then APOD, and then back to UCF and the Amateur Astronomy Society here at UCF. All right. Now, I want to use your eye clickers if you have them. All right. We're going to do a practice eye clicker question. And the question is already running. I'll display it in a second. If you don't have your eye clicker, you're going to need one this semester. I'll go over it with you in a few minutes in the syllabus. But if you have it now, you can turn it on. And what I want you to do is hold down the power button until the little square starts to flash. And then I want you to type in you can't use your phone. You can only use your eye clicker. Then type in the letters D and D again. Delta, delta. And that'll put you on my frequency. We're using frequency DD this semester. Okay, so do that. And then you'll get a check mark, and it'll say Go Nitro. All right? Anybody see Go Nitro message? One person? Couple people? Okay, good. I see you in the back there. All right, so we're just going to do a practice question. And this will help me get the sign-up roster downloaded. That's why we're going to do it. And it's just a Chuck Norris question. We'll be doing some practice questions between now and Labor Day for bonus points. So if you are already registered, as you could have done inside our web courses area, go ahead and let me actually start the question. Okay. You can vote. Oh, Heather. You press the power button down and hold it till it flashes. Then type in DD, and it'll say Go Nitro. And then you can click A, B, C, or D. Whichever one you think is the coolest Chuck Norris concept. Let me see what. This Windows computer. Okay, you guys are voting. Good. Now, one thing about it, you can, for those of you that have never used iClicker before, you can click anonymously before you're registered. Okay? But in this class, in order to get points for your semester grade, it has to be registered. So getting a check mark and the Go Nitro message in lecture does not mean you're registered. You have to register. Who's registered through web courses already? Okay, a few of you. Good. So you guys are going to be squared away. You're going to have bonus points today. Sweet. All right. The rest of you can get bonus points on Thursday. All right. Let's see what the top. Okay, 10 seconds to vote. 10, 9, 8. Are you on? 7, 6, 5, 4, 3, 2, 1, 0. All right. Let's see. let me switch over to the, this is a little difficult up here without a TA. Hold on a second. Here's our distribution of answers. It looks like most people voted for option D, and I'll be able to show you that. I mean, when we get to regular astronomy questions, you know, distance to a star and all that kind of stuff, you'll be able to see, you know, what you voted for or what everybody's voted for. So it looks like the most popular one was D, and second most popular is B. But the question is that correct? Is option D correct? And the way that I do the clicker questions, I'll always show you the answer. And there's my favorite. All right. But when we start doing regular astronomy questions on Thursday, you'll have, you know, a real thing to think about. This is just a practice one to show you how the clickers work, and so that I can get the roster synchronized. Now, I want to do a demonstration with you involving seeing. So type in the word seeing in your notes. And we're going to do some observations. David and Heather, could you come up here to help me with some stuff? I'm going to be passing around these are called student diffraction gratings. And when you get it, you can look at the lights, the overhead lights and stuff. And then I'm going to show you some special lamps up here to observe through it. And David and Heather are going to pass these around. And so take one and do not put your thumb or your fingerprints on this plastic. Only on the cardboard, okay? We don't want to get smudges. We don't want to get your greasy fingerprints on there. Right now, you guys take them by the edges. Take a couple of these. And just give them out in bunches. We're going to give them out in bunches, so if everybody on your row has some, just send them backwards. Here you go. And we're going to have to do a ton of these. So. And let me give you a couple more. Don't put your fingers on there. Okay. If you sit up front, you get asked to help sometimes. What's your name? This, and I'll start in the back. These guys are in the front. So hold it by it and just use another couple big bunches. Okay. Okay, just take those two. They come back this morning. Just you guys don't count them out. Just hand them out in bunches, and then let everybody pass them backwards. Did you guys get some? Just for you. No, that's all right. We got three. That should be good. And when you get it, hold it so that when you look at like one of the overhead lights, you get rainbows to the left and right. If you swing it 90 degrees, you'll get rainbows above and below the light, but we want to look at it so that the rainbows are left and right. All right, so it's, and then we're going to darken, actually I'm going to start working on the lights. And I'm going to turn off, I'm going to pause the podcast. Just put this on, can you put this on the ledge there? Can you stick those in there? And here's some of the rubber bands. Maybe some of them got looped, I guess. Anybody still have diffraction? Who on the aisle? Who still got them? You guys in the back. All right. You have one over there. See, I forgot to even use this. Is a gigantic diffraction grating. So like for using on an overhead projector. I forgot to use it, but all right. Just wait for this. David, there's one more diffraction grating over here. All right, thanks a lot, you guys. And while you're up here, we're gonna, in a minute, we're gonna do syllabus. We're gonna do syllabus in just a minute. Great. Yeah, these rubber bands are kind of shaky. Okay, if you're out of rubber bands, you can just stack the rest of them in there carefully. Thanks, Deanna. Perfectamente. Okay, let's just review and take a few notes on what you just saw. Spectral lines, and really a spectrum of light, whether you use a prism or a diffraction grating. We just used a diffraction grating. And if you want to know what a diffraction grating is, in this case, it's a clear piece of plastic with little microscopic black lines photocopied very carefully onto the plastic. So it blocks the light, then it permits the light to go through, then it blocks the light, then it permits the light. So it's like the bars on a jail, in jail. Not that anybody in here has ever been to jail, but so they're vertical bars going, and they permit light to go through in between the bars, and that causes the pattern. And we're going to talk about why that happens. Okay, so the first thing you saw was the incandescent light source. Okay, and then the second thing that we saw is a discrete spectrum, and it's important to use the word discrete and know that it forms the fingerprint for hydrogen, for helium, neon, and in fact molecules. Water has a fingerprint, a lot of infrared for water. Silicon dioxide, pyroxene, which is a gemstone mineral. A lot of gems are made of pyroxene. We can see it out in the universe because we can see its fingerprint. It's a countable subset of colors, so not the entire spectrum. Now, why is that? Because light behaves as a wave, just like waves in the ocean. Now, here's a picture from a satellite of waves in the ocean, and notice how at the bottom they're coming in from right to left, and then they between those two islands, they kind of, that's like the diffraction grating, they kind of bend and they head up towards the top of the picture. That's diffraction. Here's another image. This is a single opening, and you can see that the waves in the ocean, they come in a certain direction, and then they kind of curve around, as if that single opening is a new source of circular waves. When you drop a pebble in the pond, or wherever you are in the pool or something, you see rings go out, circular rings, they move out. And that's kind of what you're seeing here, except nobody's dropped in a pebble. The waves just went through that gap, and it's as if that gap is a source of round circular waves in this direction anyways, towards the bottom of the picture. Here's another picture at the shore, and you can see this one's actually a little bit more like a diffraction grating. Barriers, openings, barrier, opening, and you can see the waves kind of forming that. In fact, they form the shape of the beach there if you look at it carefully. Right? And there's a reason that they put those things up there. The other thing that controls the colors is the shape of the diffraction grating. Now we had jail bars, vertical up and down diffraction gratings. But you can make a diffraction grating with round openings, open rings and then dark rings and then open ring and then dark ring. You can do that. And if you do that, you have a different looking set of colors instead of just vertical lines. So now I want to talk about the syllabus. David, could you come up? We're going to talk about the syllabus for a minute. In this file, for that section. And Deandra, could you help with the file? And you guys over there, never mind Deandra, just take a bunch and hand them back to the side and in the back. Send them back. So just take some for your row and then send them back. So we have another 15 minutes. Let's talk about the syllabus, and we'll finish up the syllabus discussion on Thursday. So let's do another 15 minutes of this, and I'll give you a minute to get those. Yeah, so just pass them back and pass them back in bunches and just kind of pass that big pile all the way back. Pass that back immediately. Take some for your row and then pass the big pile back. Just kind of propagate it. Don't count them, just take a bunch. There you go. Take a bunch and pass the back. There you go, good. Pretty soon everybody will have a bunch. If you have, you guys up here towards the front, if you have extras, just send them back. Somebody will need them in the back. And I apologize, you guys in the back, if you don't, if there's none that make it back to you guys in the back few rows, there's a PDF in our web courses area, so you can download it. I made like 350. I don't know if that's going to be enough. Okay, take some for your row. Just pass them backwards. All right, pass them backwards, 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 backwards. We're making it. Pass them back. Pass them back. We must propagate the syllabuses. Yo, in the back corner with the phone. Are you on web courses? Facebook, huh? Gosh, because I know that's why guys sit in the very back in the corner. Who doesn't have a syllabus? Oh, who's got extra syllabuses over here? Okay, who's got extra syllabuses back here in the middle section? Yo, any extras up? Send those extras, whatever you got, over to the left side. All right, move them across. Move them across the aisle. Over here, anybody not have one? Okay, we're getting some to you, looks like. Send those, are those extras? Yeah, send them across over there. Across the aisle. Raise your hand if you don't have a syllabus. Okay, just a few more. Are there any? Who's got extras? Okay, extras, bring them over here. Bring those forward now. Send them forward because people in front of you need them. If you have extras, yo, with the extras, can you send them all the way to these guys over here? Okay, cross country here. To the left. Send those over. There we go. Who doesn't have a syllabus over here? All right, still got a few. Here they come. Get it to those guys. Raise your hand if you don't have a syllabus. All right, we're getting them there. Send them forward. People need them up front, in front of you. Everybody over here on the right have one. You don't have one? Oh! Is there an extra syllabus over here? All right, young man with the blue shirt, carry it over here to this side in the back row. Be a gentleman. Help out. Oh, did you get one? Okay. All right, never mind then. All right, let's talk about the syllabus. Uh-oh. I need one. Is there... Could I borrow yours? Thanks. All right. All right, let's take a look at the syllabus. Let me get some light. And we'll just talk about okay, the basic specs in the table on the upper left. My name, course description. Okay, my office is room 156 in the Physical Sciences building, PS 156. But our office hours are in room 158, which is on the other side of the elevator. It's a little bit bigger room. And office hours are tomorrow, 9:30 to 11 a.m. Just drop in. And office hours, I don't have anything to do. They're open for you. Drop in for 10 minutes. And you don't have to come at 9:30. You can come at 10:05. And, you know, any time in there. And whatever you want to talk about, whether it's a textbook or something from class or something cool that you saw. Yeah, any topic. Okay, my telephone number, 407-823-6286. Okay, draw a line through that and cross it out and then write the word no. Because I'm hardly ever there and I am very, very bad about answering phone mail messages. But yeah, technically that's my phone number. Twitter, brainwave777X. I usually have a TA to Twitter notes. I'll be putting stuff on Twitter about class. Okay, now, I told you don't use the phone. Do use Canvas messaging in web courses, so the inbox. Don't use conventional email. I will not respond. There's just too many of you, and love you as I may, I just cannot handle conventional email. But I'm always on web, well, not always, but I'm on web courses a ton. And so if you message me there, it's good, and it has the the feature that it's considered private. So I can talk to you about grades in web courses messaging with the inbox. I can't do that with conventional email, and that's another reason I don't use it with students. Okay, lecture, of course, 9 to 10:20. Final exam, mark this on your calendar, do it now. And if you have a job off campus, ask your BOSS today, I've got to have, freshmen. Freshmen, raise your hands. Newbies. And guess what? Your first semester, you have a 7 a.m. final. Oh my goodness. I hate 7 a.m. finals. But that's what we got. It's the registrar that decides it. Okay, so December 7th, make sure that you have until noon free just for safety, and that you're not going to, because we'll start at 7 and you're going to need all 2 hours and 50 minutes, most likely. All right? So just get that squared away. Now, if you look at the second column on the first page, you'll see the other exam dates. But those are in lectures, so I'm assuming you're already clear for Tuesday. And those are those are Tuesdays, I believe. Okay. Okay, textbook. Office hours, we already talked about. Textbook. Now, this is a free textbook. You know, I love this. I've been teaching Astronomy 2002 off and on since 2004. And this is the first semester I've gotten to choose a textbook that I want to use. Because we have so many sections, somebody usually selects it for all of us instructors. But this semester, I got permission to use this one, and we're going with a free textbook. Anybody in favor of that? Yeah. Good. Do not forget that. And I'll tell you what, I wrote a textbook for my physical science class, and I wrote, well, let's just make it an e-book. And they're still charging out the wazoo for an e-book. So I'm going to go to a free version of that pretty soon, too. So anyways, OpenStax, there's the website for it. And I'll be giving you reading assignments in there to back up lecture. And what if you want today, go in there and just fool around, see what it looks like. You can actually download, I think you can download a PDF of it if you want onto your desktop machine. Websites, web courses, and also YouTube. There's a link to our YouTube playlist inside web courses. I just put that bit.ly thing in there. But this lecture today, I'm recording it, and I will, after lecture today, I'll upload it as a video into YouTube, and you'll be able to review it and stuff like that. And when we get to regular astronomy topics, it'll be a nice study tool for you. Okay, policies. All lectures will be YouTubed. I didn't dismiss you yet. You're not permitted to go yet. Because I want, just before we dismiss, I want you to take a look at the grade scale in the back. Make sure you look at that. Go ahead and study this tonight. And there's an attendance quiz inside web courses, homework 0. Go ahead and take a look at that. Go ahead and do that. It's a Chuck Norris concept question for attendance. And then if you didn't get a syllabus, or if you know somebody that didn't, it's PDF. in web courses. Get the textbook. And I'll see you on Thursday. You're dismissed.